Hello and welcome to this presentation on ASP .NET Web API. My name is Shiv Kumar and I will take you through the paces of introducing you to the Web API Toolkit, and we'll be building a few demo applications in this episode that will introduce you to not only the Web API Toolkit but also to the ASP .NET Core framework, wherein we will be building, in fact our first demo, we will be building an ASP.NET application using the ASP.NET Core framework rather than the Web API Toolkit, so that you have a better understanding of the underpinning ASP.NET framework before moving into the Web API Toolkit, which will also give you a better appreciation for some of the plumbing that the Web API Toolkit does for us. But I think it's important to get a sense of how the ASP.NET Core framework functions and how you can tap into it to build things of your own, or even when you use a toolkit such as the Web API Toolkit or MVC or Web Forms that all sit on top of the ASP.NET framework, you understand or have a better understanding of how they actually function under the hood. So what is ASP.NET Web API? ASP.NET Web API is a toolkit that allows us to build HTTP based services. Now some people think HTTP and REST are one and the same, and they could be. In my mind, REST is a subset of HTTP. HTTP is a sort of larger encompassing protocol. REST happens to be an implementation, if you will, of that HTTP protocol. So with the Web API toolkit, we are able to build HTTP based services. They may or may not be REST or RESTful services, but they're certainly HTTP based services. The ASP.NET Web API, as I mentioned earlier, sits on top of the ASP.NET platform. This toolkit was in fact built by the same team that built the WCF framework, wherein they were pulled into the ASP.NET team and they were sort of asked to build out a first-class citizen of the ASP.NET framework, such that a first-class citizen of the ASP.NET framework that builds or allows people to build HTTP-based services. Unlike WCF, which was not necessarily a first-class citizen of ASP.NET, it played nice with ASP.NET and sort of functioned even outside of ASP.NET, but the Web API Toolkit is essentially a core piece of an extension of the ASP.NET framework. The framework does not enforce the REST architectural style, so you're free to use or build your applications just using the HTTP protocol without being forced to use REST. And as I mentioned earlier, the ASP.NET Web API can be used in conjunction with ASP.NET Web Forms, MVC, and WCF with the HTTP binding. What that means is if you have a Web Forms application, you can still extend that application today using the Web API Toolkit. Or if you have an ASP.NET MVC application, you can extend it using the Web API Toolkit. By extending, of course, is extending it as a HTTP API, non-user interface based API service. So the Web API is built on top of the ASP.NET platform or the ASP.NET Core pipeline, and is completely interoperable with other ASP.NET toolkits such as Web Forms, MVC, and such. It uses or supports the ASP.NET routing feature, so you are able to build out routes to your API without the need for any file extensions, and also being able to control routes using certain routing templates that you're probably familiar with using when using it through either Web Forms or MVC. They've introduced some nice abstractions in the Web API Toolkit that allows for making strongly typed HTTP requests and response. In other words, rather than dealing with the raw HTTP protocol directly, which you can do with the ASP.NET framework or web forms or MVC or even the web API. The idea is to sort of abstract us from having to work with the raw HTTP objects and rather work with an abstraction that look very similar to the HTTP request and response, but yet are just simple objects or plain old C# objects, such that they're easily testable as well as completely disconnected from the actual HTTP aspects of the underlying ASP.NET framework. In the same toolkit, they've introduced a new HTTP client class. That's the HTTP socket that allows you to build HTTP client-side applications that can talk to your services. They don't have to be built using the web API framework, but nonetheless they are HTTP-based services. And this client, the HTTP client class, uses the same abstractions as I mentioned earlier, or the abstractions that I mentioned earlier, such that the code that you have on the client side and on the server side end up looking the same, symmetrical, if you will. You know, you got HTTP response message on the client, you also got the same HTTP response message on the server, you got a HTTP request message on the client, you got a HTTP request message on the server, and so you're sort of working with the same abstractions on both sides, the client side and the server side, at least when you're building a client using C#. And that just makes the whole experience a lot more user-friendly and intuitive, because you're not having to deal with sort of different metaphors on the client side and on the server side. That takes care of our slides. I just have this one last slide for this presentation. Just want to give you a visual of how the web API fits in with the other frameworks or the toolkits such as MVC and web forms, along with the core ASP.NET framework. So as you can see here, the core ASP.NET framework is the underpinning framework on top of which you have MVC and web forms, and now you have the web API framework. So they all are sort of first-class citizens of the ASP.NET core. And what we're going to do in our first demo, in fact, is we're going to be building out an application that uses the core. This is not going to be a full-blown application, just a few methods that are HTTP services based methods, and we build that out using the ASP.NET core or classes that are part of the ASP.NET core framework, just so you have a clear understanding of how any of these toolkits on top of this framework work, without necessarily having to build out the entire toolkit. But once we have a sort of a semi-functioning application, we'll then move that to a web API application, so you can get a appreciation for some of the plumbing that the web API toolkit does for us and how it makes our lives a lot easier. I thought this was important because even though there's very simple ways to get started with ASP.NET in Visual Studio, web API in Visual Studio, in my mind there's just a lot of magic that happens when you say file new project and pick a certain type of project, and 30 seconds later a whole bunch of things have happened in your solution and projects, and you really don't understand what really happened. So even when we build out our web API project, we'll be starting from without using any of the file new project options, so that you get a sense of the classes that are in use, the assemblies that are in use, and the NuGet packages that you may need to use, etc. So without further ado, let's get one more slide. The demos we build will be following a somewhat REST protocol. So for those of you not familiar with REST, I want to give you a sense of some of the URLs that you would see in your APIs, or the way you want to design your URIs in your API, and what they would mean to the caller. So in this case, let's say we have a URL, a relative URI that has API/members, and if we use the HTTP get method, then that would imply that it means get all members. Why? Because we didn't specify a specific member that was identified by either a username or ID or whatever that uniquely identifies a member in your system. In this case, I'm showing you it's using the username as an identifier for a member. So if we did another HTTP GET for the same URI, but added a username at the end of this URI, then that would imply that you're getting a specific member. This is sort of the REST protocol. Similarly, if you did a post with the API/member, it would expect you to have sent in a member in the form of JSON or XML or what have you in the HTTP content part of this request. So the HTTP method was a post. The URI you called was API/members, and the expectation in this situation would be that there was a member in the form of XML or JSON, as the case may be, as part of the HTTP content of your request. If you were intending to update a specific member, then you would add the username of the member that is uniquely identified by this username, and the content, again, the HTTP content would again contain a member with the updates, so whatever was changed in the member would be part of the HTTP content in the form of JSON or XML, as the case may be. If you want to delete a member, you'd call this URI API/member/username, but the HTTP method would be delete. So given these simplistic URIs here, I'm hoping that you get a sense of how you think about your URIs, how you design your URIs when you're building a RESTful service, in this case pretty simple RESTful service, and what the HTTP methods map to. So the GET maps to the read, the POST maps to create, the PUT maps to update, and delete maps to delete. Now some of the other sort of caveats or some of the other requirements for a RESTful protocol is that some of the methods, so GET is a safe method, meaning you can call this method, you can call this API, if you will, n number of times using the GET HTTP method, and nothing untoward should be happening on the server. I mean, you might be logging stuff and data might change, but it's safe in that the core data, in this case members, don't change just because you call it 100,000 times. And in fact, a lot of the search engine bots will use the GET method to call into your public domain website to index it, with the idea or with the understanding that calling a certain API or URI with the HTTP GET method should not change anything for you, at least. Shouldn't have to worry about data being lost or updated because some search engine bot came along and tried to index your website. Idempotent methods are again GET, so GET, PUT, and delete. What that means is you can call the method n number of times. Some data might change, but there should be no untoward behavior. So in the case, for example, of a PUT, the very first time, of course, the data was updated with the new data, but if you call PUT again and again and again 100,000 times, the same data is being modified, but that should not have an impact to your system. You shouldn't sort of have a problem because somebody's updating a member with the same information over and over. Similarly, if you deleted a member, the first time it did get, the member was deleted. The next time, of course, there's no member, but the method should be idempotent, meaning a client application should be able to call the delete method n number of times, and if that member does not exist anymore, it's okay. You should not blow out saying, sorry, member was not found. So that's what the meaning of idempotent is, that you can call the method, certain methods n number of times. So GET, PUT, and delete are idempotent. GET is also safe, meaning nothing should really change. Well, idempotent means there should be no untoward side effect, if you will, besides the actual intended effect. But once that effect has happened, you should not then have a problem the next time. We'll be looking at our implementation for a RESTful service in this episode and the next ones. But intent is not to teach you REST per se, but just to show you how you can use the Web API toolkit that's part of the MVC4, or KML was released as part of the MVC4 toolkit as well. Okay, let's look at some demos now. So what I'm going to do is I'm going to start a brand new project, and I'm going to just use a ASP .NET empty web application. I'm just going to call it web application 1. Now in this application, as you can see here, there's not a whole lot of stuff in there. So all we have is this application. There are no pages. There's a config file, but there's nothing else in here. Now to this solution, I want to add a an entire project, and the reason I'm doing that is because this project per se is not relevant to the our demo here, but we're using it. So I'm going to add, I'm probably going to open this folder, and just so you can see here, I'm going to paste this existing project in here so that I can now add existing project. And this is the so I'm going to add this project to the solution. This is the domain layer part of the project, meaning this is the UI piece or the service interface layer of the application, and it's all it's doing is sort of translating the HTTP information into a call into this library, which is the entire business system. So for those of you not seen the presentation on my YouTube channel called Layer Architecture, this project is following that concept where this is the business layer. This uVideo project is the business layer, known as in my language, the domain facade. So the web API project is just going to be using the domain facade to get access to all of the functionality, and the functionality is kind of built in here, so we're only going to expose it via an API from our web API project. So the first sort of implementation of this project is going to be using the core ASP.NET framework, and so we'll be working with what they call handlers, or HTTP handlers, rather than the web API controllers. So I'm going to add a new folder here. Let's call it handlers, and to this handlers folder I'm going to add a members handler. And this members handler, actually I'm going to have a handler base class first, and this base class is going to implement our HTTP handler. This is, as I said, this is part of the ASP.NET Core framework, and what you're required to do is implement this interface to the HTTP handler interface to make this handler. And this is the base handler because I need certain base functionality in my base handler so that all my other handlers don't need to repeat that, so I'm able to inherit certain functionality. So in this case I'm going to just return true, which is unlike, for those of you who might not be aware, all controllers and pages are descendants of handlers. So every controller, MVC controller, web API controller, and web form is a handler, is an HTTP handler. But in their case, the is reusable is set to false, meaning each time a request comes in, that page or the controller is reinstantiated, whereas here I'm just setting it to true so that it's reused each time rather than being recreated each time. And what I'm going to do here is I'm going to call a method called process request score. Essentially what I'm wanting to do is to have this method overridable by descendants, but because this needs to be protected, and in this case it's going to be abstract, as per the framework design guidelines, you don't make abstract or virtual methods public. So this is the public method, but descendants will override this abstract method. So I'm going to just make this method abstract. As a result, this class should also be marked abstract. So I didn't have to do it like this, but the idea, what you want to keep in mind is that there's just a base handler, And the reason it's a handler is because it implements the IHTTP handler, which is part of the ASP.NET framework. Okay, now that we have a handler, we can add to our handlers folder a new class. Let's call this members handler. So this members handler now descends from our handler base, and it will then be forced to implement the process request core. Now the magic is going to happen in here. So everything we do, every request to this handler is going to come into this method, and then we need to make some decisions and probably call out to some other methods, eventually call out to the domain facade and get access to the data and other functionality that's part of this business, part of the system. So, and the reason I have a base handler here, and let's go back to that base handler class, is that I wanted to have access to the domain facade. The domain facade is the class that gives me access to the entire business system that I'm trying to front as a API or a HTTP service endpoint here. So before I can do that, I need to add, and this is my style of instantiating a domain facade within any ASP.NET application so as to give you access to your domain facade from every or from any context, such as MVC, web forms, or a web API controllers and such, because they all use the same underlying framework. And also the idea or notion of not having to create instances of this domain facade for every request, and it's going to be cached by, in this case, global. So I'm going to add a new class here, and this is going to be the global application class. And I'm going to add that. I don't need, I'll leave this app start, but I don't need any of the other events here. So I'm just going to delete those. And what I'm going to do is I'm going to implement or override the init. Maybe in another episode I'll explain the sort of underlying concepts of this whole thing. Idea here is that the init method is called only once. It's almost like the constructor, but because of some of the nuances that happen in the ASP.NET framework, if you use the constructor, it's not going to work out the same way. And what I'm going to do here is I'm going to associate a domain facade instance. I'm just going to call it, and I didn't actually add a reference to this project, so let me go do that as well. So to this project, I want to add the reference of the uvideo project here, and I'll have access to this domain facade. And this is just going to be a private set here. And so what I want to do is I want to new up and assign. That's it. Oh, I shouldn't actually do that. Okay. So when global gets initted, think of it as a constructed. So every time there's a new instance of global, which is not for every request, but IS will cache instances and associate them to threads. But that's another topic, another discussion. We have an instance of a domain facade. What I want to do now is to have access to this instance from every one of my handlers. So I'm going to define a method, a property in here that is also of type domain facade. There's nothing to do with the web API itself, toolkit itself, but this is how you should do things, and also you'll get a better sense of when you move to the web API side of the demo that nothing really changed. So it's the same concepts apply, and that's one of the other things I want to show you here, is that because web API is built on top of the ASP.NET core framework, whether you're using the core framework or web API, the concepts will remain the same. Okay, so now this domain facade here, this is our same domain facade, but rather than newing it up and doing all the stuff it did, and there's no set method here, what I'm going to do is I'm going to get access to the instance from global. And the way you do that is you do HTTP application dot, sorry, HTTP context dot current dot application instance. This is the application instance that you are currently running in. This handler or that handler instance is running in. So as per this instance we know is global. So I'm going to cast this to, and global only because that happens to be the name of our class here. So if the class is called something else, then you'd use that instead. And global has a property called domain facade. So that's domain facade, and that takes care of sort of getting a reference to domain facade from the current application instance. And once the base class gives us access to this, oops, sorry, this needs to be returned. Once the base class gives us a property, this is wrongly spelled. Let me. Okay. So now every descendant handler in this case has access to, so I could actually just say domain facade dot, and you can see the domain facade has various methods like get members, get member videos, and so on. So without trying to explain how that works, I want to just show you how you can slap on a thin HTTP service endpoint on top of a entire business system without having to alter the business system. So in here, what I want to do is, based on the kind of request, I want to do a few things. So I'm going to define a method here, which could be private in this case, that returns an enumerable of member. So this is like the members version of the call. And I'm going to call this get members. And this implementation is going to be pretty simple. It's just going to say domain facade dot get members, right? Because that returns also the same thing. Member, of course, in this case is part of the domain facades, the uvideo project. So I pull that in, and this should be get members. And so what we want to do here is we want to say, well, if the context dot HTTP method, sorry, context dot request dot HTTP method equals get. Okay, so if it's a get, and if you remember the URI, so let's say we had a URI that said in the slide I had a URI something like this: API/members. So if I just did API/members, that meant get me all members. But if I did API/members/ the username, in this case our data uses ID, or the member ID, as the unique identifier. So let's say if I did that, that would be get me a singular member. But this portion of the URL is called path info. So what we're going to do here is we say if context.request.path info. So we could do this if string dot is null or empty. That means there's no path info, so there's no ID. Then we could just call get all members, so get members, right? And what we're going to do here is we're going to define a data. Let's call this not data but output. I'm going to actually have this as dynamic. All this is not required. I'm just trying to make it such that you understand what's happening behind the scenes in either a web forms application or an MVC. Certainly an MVC controller will be doing something similar, because what we're implementing here is not an extremely robust method dispatch logic here. It's very simple. If it's get do this, if it's supposed to do something else, and we're not doing a whole lot of validations and checking here, but the basic method dispatch, imagine this to be your controller's method action, get members, and so something dispatches to this, something internal that you don't know or can't see is dispatching to this method. That's what I'm trying to show here. So if there's no path info, then just call this get members method, and this get members method will be assigned to output. the result of that. But if there was a path info, and again, as I said, this is a very simplistic implementation. It's not a robust or production quality implementation. So if there was a path info, I'm going to blindly cast that path info to an integer. So let's call this member ID, and here we'd say context.request.path.info, and I know the path info, the first part of the path info will be the slash, so we'll substring it to the 1, meaning the second, and actually we will just do this in one line. So member ID is equal to nothing but int.parse that. So we should have as a member ID in the form of an integer, and then we could call another method here called getMember, the singular, that returns a single member, a specific member, and it takes in a member ID as a parameter. We should call the domain facades getMember, passing in the member ID. So one of the things I wanted to also understand here is, in case you're not already doing this, your controllers, handlers, web pages, they don't have the meat of the functionality of the system. They're doing a translation. There's only their sole purpose. In the case of API based controllers, as in a service interface layer that's not doing UI but it's just doing API, exposing an API, certainly the only thing you're doing is you're harvesting the information from HTTP, whether it's URL, content, whatever, translating it into C#, and then calling into another object, giving it the data. So if you can see what I mean by that, so I'm harvesting the information, in this case the member ID, from HTTP. So of course this whole piece here knows or understands HTTP, so it knows that path info is something to do with HTTP and how it's going to come. I extracted or harvest that information from the HTTP-ness of things. I convert that into typical types, in this case an integer, and from that point forward I'm calling into some other object that just knows how to deal with the non-HTTP things. So in fact these methods are non-HTTP based methods, even though they're part of this controller here. The idea is that the first thing you're trying to do in these controllers is to harvest information from HTTP, and from that point forward you're just making a call into a regular C# class that has the functionality you need. This class in this case is the entire business system. The same domain facade can feed into an MVC application, can feed into a web forms application, could feed into a web API application, or just a core, in this case ASP.NET framework application. So it doesn't really matter, the functionality remains the same or the business functionality remains the same. So you're able to expose your business functionality through an ASMX, which is SOAP, or WCF, whatever the protocol may be, or binding that you choose, MVC, web forms to provide a UI to the same information, same data, a web API to provide a HTTP service. So once we have a member ID, we can call into this method. So getMember, given a member ID, and this returns a singular. So again, I'm just going to assign it to output, and that's the reason I made this dynamic. It could take on any form here. And once we do that, we want to, in this case, we're going to blindly convert this into JSON and serialize it. So I haven't added the Newtonsoft assemblies here, so let me do that. So I'm going to install a NuGet package, and it's called Newtonsoft.json. Install that. So now I have access to the Newtonsoft JSON in my web project. So not in the uVideo project, but in the web project I've added this reference here. And I should be able to just say over here JSON convert, which has to be in a specific assembly namespace, JSON of Newton, and I can say serialize object. So object in this case is output. What that's going to do is going to give me a JSON string. So let me assign this to JSON and then I'll do context dot response dot write the JSON. So I'm doing this all by hand, manually. Behind the scenes, MVC, web forms, and web API will do their own thing to do all this, so make this kind of seamless to you. But we're doing this by hand. We're getting down and dirty and doing this stuff by hand. So whatever the output of either of these two methods is, in this case, an enumerable of member or member, the logic here is saying if it's a get, then either call the get members or call the get member with an ID. Nonetheless, whatever the output of these two is converted to JSON and serialize it out. Now, the way handlers work is they need to be registered in the config file. In this case, again, our handler is by hand. We're not using an ASHX extension. So what we need to do is we need to register in our config file this handler and let the the ASP.NET pipeline know what to do when it sees. So system dot web server section, and the web server section is used when you're using IS 7 and above. If you're using IS 6, then you need to use the system.web section. So in this case, there's handlers section. There's a handler section in system.web as well. So you would be doing it over here like that. But we're going to do it since we're using IS 7. And to this, we're going to add a handler. Now the name is just some user-friendly name of yours. We're just going to call this members handler. I guess it needs to be unique in the list of names that you're adding to the handlers here, but it's your thing. It's nothing that it relies on. Then the path here, instead of using API slash, I'm just going to have h slash members. So that when we do our web API project, we can use API slash. Even API is just a convention, it's not a requirement, but I know that people are used to seeing that URL in that way, so we'll just call this h slash members. The verb, it doesn't matter what it is, get, put, post, delete, head, etc. It's all of them. And the precondition is managed module, I think. Hopefully that's the right one. But so the idea is that you're registering a handler in your application, and you're saying if you see a path of h slash members, then instantiate this type of class. So instantiate for me the class that is known with in this namespace. So essentially, you want the namespace plus class name. That'll be so when you see a path in the URI h slash members, then instantiate an instance of this handler and call it. What's it going to call? It's going to call the process request method, which in turn is calling the process request core method for the descendant. So our base class is forwarding it on here. So this method is going to be called for every request that is headed for this handler if the other conditions, as in the verb in this case we don't care, but if the path is the same, it's going to instantiate an instance of this guy and call the process request message, a method which in turn calls process request core, which in turn comes here. So to make our lives a little easier, I'm going to also make the default page of this application be h slash members. So we don't have to keep typing it in. Now I'm going to run this, and what we're going to see is okay, so manage module is not the right precondition. I think it's integrated mode, not managed module, but integrated mode. So essentially integrated mode tells IS7 to treat this handler as part of its own pipeline, which did not used to be the case in earlier ASP.NET versions. So in ASP.NET 2.0 they introduced the integrated mode versus the ASP.NET classic mode. So anyway, that's it. So if I run this So once we step in here, since I can't use the keyboard, my recording thing pauses the, actually not pauses, stops the recording when I hit F10. So I'm going to step, and you can see the method, HTTP method here is get and the path info in this case is an empty string. Sorry, this thing keeps fading out, but my shortcuts collide and the hint disappears when I try and zoom into that. I could do like a live zoom if that helps. That's the other problem I have with this, it flickers a lot. But anyway, so the path info is null, so it's going to go into here. It's going to call into this method here, call the domain facade, returns the 9 enumerable members. We don't have to see or test that. We can just assume it's coming back with the 9 enumerable members here. So you look back in here, you can see it's a 9 enumerable, and we got 3 members here. Now just so you know the names of these members, there's Luke Skywalker, of course. You got Obi-Wan, and then you have Anakin Skywalker. So the 3 famous musketeers from Star Wars. And then you step in, and this converts into JSON. You'll see that there's a JSON string here, the standard JSON array. So you can see this is an array of JSON objects, and we write it out to the response. So what we get back from our call is JSON. So now one of the things we did not do here is we didn't set, if I were to run fiddler and do the same call again, so what we have with fiddler is that look at the raw. Okay, so it was gzipped. So if we look at the raw information now, you can see that there's a JSON string here. But what we've not done is we've not followed the HTTP protocol, in that we haven't told the client, in this case fiddler or the browser, to expect JSON or XML or whatever it is. We haven't responded in the right manner, even though we're seeing the data correctly. The browser doesn't necessarily know what to do with it. And in fact, one of the reasons that this browser IE is showing us this data is because it's expecting the data to be text. So you can see the content type here is text XML, HTML, and so IE is rendering this information as if it were text. To follow the actual HTTP protocol, we would need to respond with a content type of application JSON. So let's do that, and what's going to happen then is that, of course, IE doesn't necessarily work. IE doesn't have a default behavior for JSON, but nonetheless, we'll see it in Fiddler anyways. So before I actually write out the response, I'm going to do a few things here. I'm going to say content or response dot status what's going on here? HTTP this is status HTTP status code is equal to 200. 200 in HTTP, in the HTTP protocol, implies everything is okay, and then we do a context dot response dot content type is application slash JSON. So that's the expected content type. These content types are defined by the Internet Task Force. So it's not something you just dream up and put in there. But I happen to know that it's application slash JSON, and so we respond to this. So what happens now is the calling side application, be it a browser or Fiddler or your own application, is aware of the content type and so it knows how to respond. So in some cases, some browsers know what to do with JSON, some browsers don't, and you'll see that IE in this case has no idea what to do with JSON. Chrome, in fact, does show you the JSON in the browser, just like we saw IE do when it thought it was text. So if we run this again, this time in IE will want us to open a file, and in this case, when I open the file, I see the JSON in the file itself. But I've also seen it in Fiddler. So if I look at the Fiddler trace here, you can see now that this is JSON. The raw is still the same, but what's happened is the content type has now changed to application JSON, because that's what in fact we sent or returned as part of our response, and we also returned the status code of 200 as part of our response. So what you've seen here so far is that we have implemented a get member and get members method. We haven't tested this yet, so let's also test this part. The response will be the same, as in it's a singular member, so the status code, if everything goes okay, is still 200, and the content type is application JSON. So let's move and look at how to execute the get members singular method here. So that seemed to have closed Fiddler again. So I should probably also capture the request so I can alter it. So if I look at the Fiddler request now, the raw request here is going to h/members, but there's no path info, no /1, 2, or 3. And so what we're going to do is we're going to compose our own request here by copying this one over. So now we got the same thing here. And also notice that so far we've not told the server side that we accept any specific type. In this case, we are accepting text HTML, application XHTML, or anything else. We haven't told it, our server side, specifically that we are expecting JSON. Now again, to be sort of players in the HTTP domain of follow the protocol, we should respond to what the client sends us. So if the client doesn't send us an accept header that contains application JSON, then we shouldn't be responding with JSON. In this case, it says that it accepts application XML. We should be responding with XML instead. Now we won't be implementing this feature in our little application here, but this is something that happens for us out of the box. And the Web API framework is called content negotiation, and it's automatic. So it looks at the framework looks at the HTTP headers and says, oh, you accept, and these are in order of precedence. So the first one, if there was application JSON here and application XML, the framework would respond with application JSON, just because it takes on a higher precedent than the next one, and so on. In our little toolkit, we are not responding to. We could say, well, if it's request.headers or accept has JSON, then respond with JSON. If not, if it's XML, respond with XML, and so on. We won't be doing that here. But what I want to show you is now making a separate call. So we want to say members/1, and when I hit enter here, I should see it's a 200, so everything is fine. And what I see is just the one member that has that ID of 1. If I change that to 2, I should see Obi-Wan instead of Luke Skywalker. If I change that to 3, I'll see Anakin. So just so you can zoom in and you can see the single member coming in with the HTTP URI as that. So I'm saying I want to get members number 3, and I get Anakin in this case. Now if I put in a number that does not, I know there's only 3 members, so I put in a 4, some member identified with the ID of 4, I'm actually going to get a 500. And the 500 indicates in HTTP terms indicates an internal server error. But really, we don't want to say internal server error. We want to say this member was not found, which is actually a 404. So we won't be doing this in our the ASP.NET implementation part, but we'll be doing this in the Web API implementation, whereby some things we still have to do in the Web API toolkit to follow the HTTP protocol sort of more perfectly. In the handlers, we have to do things by ourselves, where we're dealing directly with the response and request, whereas with the HTTP, the Web API toolkit, things are a little more abstracted. So we'll be looking at implementing the proper responses in those situations where the member was not found to return a 404 instead of a 500 error. But nonetheless, I hope this little exercise here explained to you how we're dealing with the raw at the ASP.NET framework level, the HTTP context that includes request and response, and how we can make certain decisions, and based on these decisions we can dispatch to certain methods with certain information. And the idea that you would have a business system, in this case our domain facade class, that is made available to us through handlers or controllers or pages via global, and therefore be able to reuse those instances that are cached by IIS, and at the same time the same functionality can be exposed via an MVC page or a web forms application, UI application, or an MVC controller that is handling just service-based calls, or a web API project that is handling exposing your functionality, in this case the domain facades functionality, via an HTTP based protocol. So next up we'll be looking at starting our doing the same thing with the web API controller. So before we get started with the web API version, what I'm going to do is I'm going to start a new project just to show you how you would normally start a new web API project. So you have a few options. I'll just show you the one option. So the one option you have is let's say you're on a MVC4 application. You already have an MVC4 application, or you're building an MVC4 application, and as part of that application you want to use a web API controller. So that's one way to do it. And of course, once you have an MVC or a pre-existing MVC application, you could just add new web API controller if you wanted to do it that way. We won't be doing this in our case, but I just want to show you that there's other ways to do this. And in fact, when you do that, a lot of the NuGets and things that you require for that project to function correctly are automatically downloaded for you by Visual Studio. So going back to our project here, so inside of this web application, I'm going to add a new folder, just like the handlers folder. There's going to be a API controllers folder I'm going to create, and in there we'll create our API controller by hand. So this is just like we did earlier with the ASP.NET framework. We're now going to do this with the web API framework, but also by hand. So I'm going to add a new folder, and let's call this API controllers, and in here I'm going to add a new members controller. So at this point, this is just a regular class. It's not a controller by any shot of the imagination, but it needs to descend from a class called API controller. But we don't have this API controller class in our project because we don't have a reference to the NuGet. So I'm going to add a new package, install package. In this case, it is Microsoft.ASP.NET.WebAPI. And that's going to install a bunch of assemblies, packages. And then once we do that, in fact, if we wanted to just look at the added references, there's quite a few of them. Let me see if I could point them out. You got system.out web. So these three, system.web.http, I think web host as well. Yeah, web host as well. So there's just a bunch of assemblies that have been added to this project by just adding the NuGet. So now we can descend from our API controller. And in this API controller, now API controllers also support routing or use routing. So what we need to do now is add routing in our project. So we already have the global CS file here, and in here I'm just going to add routing table, route table, sorry, which is in the routing namespace, route table dot routes dot map HTTP. Okay, so one of the things I don't like with the extension methods, you'll never get the help. You don't know what there's actually a map HTTP route like that, but you don't see it because it's an extension method. So you need to know what namespace it's in, and it's in system.web.http, but you have to know that in order to be able to use it. So now you'll see that there's a map HTTP route, and it takes a name parameter. I'm going to use the named arguments syntax here. Let's just call this API controllers, and then we have a route template, and the route template very much like the ASP.NET MVC templates we're gonna have. Now by default they always add the API slash something. We don't need to do that, but I'm going to follow that convention here. I don't want to unnecessarily add more nuances, but you don't have to have API slash. It could be something else, and the only reason you would do that is so there's no collision from a routing point of view with your sort of API controllers versus your other controllers, or API controllers versus pages and so on. So, and that's the same reason I used in our handlers, you know, it was H slash members rather than API slash, because in this case again the controller is members, so there would have been a collision if you used API in both cases. Then they both have the same path, route path. So in this case API slash controller slash ID, and then we have defaults new. In this case I'm just going to say that the ID placeholder has a default route parameter dot optional. So the ID is optional. So we defined a route for our controllers. In this case we just called it API controllers, and that's the pattern or the template that will be used. So API slash members will resolve to our members controller, and if we provide an ID, it'll still be routed to that members controller. So now in here, let's first implement the get all members version, and we just say get public enumerable of member. It doesn't know what member is. In this case we need to add the namespace. We call it get. Now as web API controllers go, we don't have to say get members. We can just say get, and it implies that and because there's no parameters in here, it implies that this is going to get all members in this case, just because of that HTTP sort of the REST protocol pieces. If you remember, let me bring up the slide. So the get without an additional parameter and using the HTTP get method will return all members in this case. So we're returning an enumerable of members here, and here we would like to have access to our domain facade. Now I could have a base controller that descends from this one, and then this controller descends from our base controller instead of this one, and we would have access to our domain facade. But for now I'm just going to copy this over here, so we have access to our domain facade, instance from global. So it's the same instance that is available in global. We make it available over here. So again, to show you that there is this common platform that all of these toolkits are sharing. And so if we work at the ASP.NET Core level, we can share some of the commonality across these toolkits. So we here could just say return domain facade dot get members, right? And that's it. So we're done with that piece implementation. So notice how simple it was for us to implement the get all members method here in this members controller, as compared to our members handler, where we had to do some sort of a logic, do some of the plumbing, method dispatching, also send back the application JSON over here as a response type, and then do stuff. So even though there's not all difficult stuff, the members, the API controllers, in this case the base controller, has some of that method dispatching ability built in, so we don't have to do it ourselves. If we want to try and access this from Fiddler, let's run this. So if you look at this here, instead of h.members, we're just going to do API.members without a parameter, right? And let's we don't need this breakpoint here anymore. Let's run this, and what we get is all the members. Let me put a breakpoint here so you can see it actually hitting the controller here. So I'm going to hit enter in this again. It comes in here and returns, and what comes back out to Fiddler is the, if you look at the raw, it says application JSON, even though we didn't have any code written in our controller, in the API controller, to say, hey, I want to return this as application JSON, and it came back as application JSON here. And the funny thing is that in here it says text HTML and application XHTML, so it should have returned this to us in XML. So if we change this back and when the accept header to be application /XML, so let's say we just want this back, we only accept application XML to the same URI, we hit enter, comes back. But if you look at the the raw header, response, you'll see that this is actually XML. So the content type now is application XML, and the response also is in the form of XML. And this is sort of the beauty of the Web API framework as compared to our the low level built by hand ASP.NET Core level handlers, where we had to do all of the plumbing and the method dispatching and stuff ourselves. The Web API controller toolkit allows us to concentrate on just the pieces that we're interested in implementing, while it does the heavy lifting, the plumbing and the method dispatching, and following the HTTP service protocols, if you will, HTTP protocols, and by way of the accept headers and content types and various other things, the content negotiation, as they call it in the Web API toolkit. So by simply changing the accept header from application XML to application JSON, no code changes were required. Just gonna hit enter here. Comes in here again. When it comes back this time in Fiddler, you'll see that it's a JSON, right? If you look at the raw, it says application JSON and this. So by default, I believe that even if you didn't put it in a header, accept header, it'll return or respond with JSON. That's the default for the Web API framework. So still JSON. Okay, I'm just going to put this header back here so nobody gets confused. Okay, so far we've implemented this one method. Now let's implement the next one. And in here, this is going to be get the sort of a singular or a specific member given an ID. Now it's not going to be called member ID here just because our the template said ID, not member ID. So I'm just going to use ID here. And in this case, we're going to get member with a singular ID as the parameter. And this is going to return a singular member. Okay. So let's see, just check that method out. I'll remove the breakpoints for now because it's not like we need the breakpoints. But so get member, and let's say I put in a 1 here. So it comes back with a 404 not found. And it says HTTP resource was not found that matches the request URI, blah blah blah. API/member. Oh, it should be members/1. So okay, so now we got a 200 back, and we got the one member in here, Luke Skywalker. And I could do the same for 2 and 3. Let's do 3. So we should get Anakin coming back. So that's Anakin here. Okay, now what would happen if I did something else? Let's say 4 or 50 or whatever, it doesn't matter, something that doesn't exist. What we get is a member not found exception being thrown by our domain facade. So it's throwing a member not found exception, but by the time it comes back out over here, it shows up as a internal server error or a 500 error. So in the HTTP protocol, a 500 error is something like went really wrong with the web server or the web application. But in our case, it's not something like totally went wrong. It's just that there was a not found. You're asking for something that we don't necessarily know, or we can't find it. It's a resource that's not been found. So we should be responding with a status code of 404 not found, rather than an internal server error of 500. So now let's look at how we would implement that with the web API framework. So back in our controllers here. So in this method, essentially what we want to do is first of all we want to catch a specific exception, member not found exception. Member not found exception, which is really an exception that's thrown by the domain facade in our case here. And again, different business scenarios might say, well, if you're asking for a member that's not found, don't throw an exception, do something else instead. Well, that's possible, but in this scenario, the domain facade says, well, if you ask for somebody that doesn't exist, I'm going to throw an exception. So in the case that the information is, or the member is found, again, instead of returning a member here, I'm going to make a change to be returning an HTTP response message. And this is one of the abstractions that I was talking about when we were looking at the slides, that you're kind of dealing at a one level higher abstraction rather than dealing with the raw HTTP and raw HTTP context, if you will, allowing you to not only test your applications but also be removed from a layer of abstraction. Unlike what we were doing in our handler, we're dealing with the actual response and request and all these sort of things, whereas with the web API controller will be at a level of abstraction. So rather than returning a member or an array of enumerable of members, we could just return an HTTP response message, and I'll show you how that works. So over here, let's have a member that is from there. Of course, if this call succeeds, then we'll actually have a valid member. And in that situation, we will do a request dot create response, in this case a specific response, a strongly typed response of member, and the status code in this case, and this is a nice enum rather than having to remember values. So HTTP status code of OK is 200. If you go in here, you'll see there are a bunch of status codes defined in this class. So you can see there's 200 over here, there's a 301 or 302 for redirects, there is a 404 for not found, and so on. So you don't have to remember the numbers, but you kind of remember the enum, and you can get to the value. And this takes in a second parameter of the member itself. So what we're doing is we are returning a HTTP response message that contains the member status code of 100, and this will do the needful, as in you don't have to worry about what happens behind the scenes. You're just dealing with the HTTP response message, and what you should see is there's a status code of 200, and what also is happening here is setting the location, or maybe we need to set the location header here. No, sorry, I'm my mistake. I got confused. This is for the get. It handles all of the requirement. But when there's an exception, what do we do? So when there's an exception, first of all, we want a response message, and this will be a new HTTP response message, and the response message has a status code or HTTP sorry, that's supposed to have been response message, not request. Status code, so HTTP status code of in this case there's an error, but it's not a 500, it's a not found, right? So it's a not found, and once we have that, we can do response message dot content. Maybe what I should have shown you before doing all of this, let me finish this and I'll show you what I meant to do. I skipped over new string content that has e.message, so the actual message from the exception. And then what I'm going to do is I'm not going to throw, I'm going to throw a new HTTP response exception, and this response exception takes the response, HTTP response, back on. And the reason I'm throwing an exception in this case is that you may have some programming in other scenarios. You might have some programming after this, and you don't want it to continue on. You want to kind of for it to exit from here. So I'm throwing another exception here instead of rethrowing this one, and this will wrap up the response exception and things that we define here. Now, before all of this implementation, so let me just comment this out. What we had was essentially returning this. I'm just going to go back to what did we actually get? Oh, actually, we have it over here. So if we look at the 500, you see that it's giving you a bunch of information that you probably don't want your users to see. So it's saying there's an exception occurred, the stack trace. There's a message here: no member with an ID of 4 was found, which might be okay, but all the other stuff that you're seeing, the stack trace and everything else, you probably don't want to see that. So that's the other reasoning for why we want to control the exceptions. So I'll just undo this anyways. All right. So what we have is we re-implemented this using HTTP response message instead of member, and in case the member is a good found member, we'll return a response like this, but in the case of an exception, we will return the response this way. So still throwing an exception, so we're not required to actually respond with this type, but in this case it is one of those types. But the throwing of a new exception means it'll shoot out of this method and go back up the call stack. So let's test out this implementation to see what happens with in Fiddler for the same exact method. So I'm going to redo this method here. So members of 4 should throw an exception. So we see an exception in the debugger here, and what we see in Fiddler is a 404 rather than a 500. We are seeing a 404, right? And if you look at the content here, the content is no member was found with an ID of 4 was found. So this is also much cleaner in the sense we don't see the stack trace and things, but the calling system is just seeing this portion, the stuff you want them to see. If you look at the raw, you'll see there's a 404 with this message. That's it. So that's one way to have implemented this is the sort of the better way, if you will, the RESTful way of doing it, but also it's an HTTP way of doing it. You are following the HTTP protocol more than you're following the REST protocol in the sense of the responses here. Now, one other thing I want to show you before we move on to the other methods, instead of doing the gets, we are also going to be looking at the put, post, and deletes, the other sort of CRUD operations, if you will. But one of the things you want to notice here, or I want to bring to your notice here, is that let's say I had a method that said HTTP response message get member by ID. Let's say that was the method you wanted over here, and over here this was member ID. Okay, so one question is, let's also do the same thing here. Actually, I'm just going to copy the entire thing, and this will be member ID. So instead of having a get with an ID, I have a method that says get member by ID given a member ID parameter, and then I do the same thing as calling the same method. The question is this going to work, or can we have such a thing? Can we have specialized methods that are not named as per the HTTP method get, put, post, delete, but some specialized names? And the answer to this is that the Web API framework routing and method dispatching actually does support these kinds of things. So when it looks at this method, it says, okay, well, if you called the service using the HTTP get verb, then this method is one of the possible methods that's going to get called based on additional criteria. So they're all get, therefore they will all be potential candidates to be dispatched to in that specific request. In this specific case, if there's a parameter called by the exact same name, member ID, not ID, but member ID, then it'll dispatch it to this method. So let's see how we can invoke this method now. I'm just going to put a breakpoint in here. And what I would do that in that case is, instead of saying members/4, I would say members : member ID equals 4. And now it sees a query string parameter that has a specific name. When I hit enter in here, I guess it didn't. I should probably run it. It wasn't built. So if I run this again, okay, it comes in here. So the member ID in this case is 4, if you can see that. And so it called into this method instead of the earlier one over here. So that's another way. There's many other sort of features / nuances in the Web API routing that you might have to get familiar with in case you have some of these specialized methods that you want to be able to call. And also there's ways to hook into these into the routing and do your own sort of logic, if you will. So there's lots and lots and lots of extensibility points in the Web API framework that will allow you to extend or change the behavior of the pre-existing or the existing out-of-the-box behavior to something that suits you better. So we're done in this episode with regards to the introduction to the Web API toolkit, and in the next episode we're going to be looking at a few things. We're going to be looking at building out the other methods. So far we've only done the gets. We'll do put, post, and delete, and we'll be looking at calling the service using another C# service application, which is a C# application built using the new HTTP client. So if you look at remember my slide here, this brand new HTTP client class that uses the same abstractions such as HTTP request and response message. We'll build a simple HTTP application that calls our service, and we could do, given how much time we have left, we might also look at building a JavaScript or JavaScript jQuery based application that ends up being the client calling into this service. So until next time, have a good day, all of